Hi, I'm Jeannie with the National Weather Service in Tallahassee. Today's topic is thunderstorms and lightning safety. We will discuss ingredients needed for thunderstorm formation, the thunderstorm life cycle, different thunderstorm types, radar basics, and lightning development and safety. There are three main ingredients necessary for thunderstorms to form: instability, moisture, and lift. Warm air rises and expands. Cool air sinks because it is more dense. Warm, moist air is especially buoyant and has the tendency to rise. Cold, dry air is especially dense and will sink towards the Earth's surface. In an unstable atmosphere, air will continue to rise on its own. An unstable atmosphere is characterized by warm, moist air near the surface and cold, dry air aloft or well above. In this example of instability, the sun is heating the ground on the right and the warm air is rising. This area has instability, which is also called unstable air. On the left, clouds are blocking most of the sun's rays. This area is more stable due to less heating from the sun. So solar radiation can create an unstable air mass near the surface. This is why we have more thunderstorms in the summer. The second ingredient we need is moisture. When water evaporates from ocean surfaces, moisture is transferred to the air. Water floating in the air is in the gas state. This is called water vapor. Moisture is a measure of water vapor in the air. Oceans are the biggest moisture source. Wind can transport moisture long distances. Water temperature plays a huge role in how much moisture is added to the atmosphere. Evaporation is higher in warm ocean currents. Therefore, more moisture is in the air near warm ocean waters. In the southeastern U.S., the warm water from the two moisture sources, the Atlantic Ocean and the Gulf of Mexico, helps explain why there is much more precipitation in the southeast as compared to the same latitude in Southern California. The third ingredient we need is lift, a mechanism which forces the air to rise. Most common lifting mechanism is a frontal boundary. Fronts are the boundary between two air masses of different temperatures and therefore different air densities. Warm, moist air is forced to rise along the boundary as cool, dense air remains near the surface. Other sources of lift are sea breeze boundaries, terrain, and outflow boundaries from thunderstorms. Sea breeze boundaries and outflow boundaries act like mini cold fronts in the sense that cool air is moving and forcing warm, moist air to rise. Terrain or mountains act as a physical barrier that forces air to rise. For severe storms to develop, we need wind shear in addition to instability, moisture, and lift. Winds get stronger as you go higher in the atmosphere. In the cool season, the upper level winds can get much higher than surface winds. This difference in wind speed creates a turning of the atmosphere, which leads to severe weather. In the cool season, thunderstorms that produce tornadoes or wind damage require wind shear. Thunderstorms have a life cycle. They grow, mature, then dissipate. The first stage is the towering cumulus stage. In this stage, the storm is forming and growing. Warm, unstable rising air is called an updraft. The towering cumulus stage is dominated by updrafts. Updrafts make the cloud grow taller and taller. This stage can produce lightning and some rain. The next stage is the mature cumulus stage. As warm air rises, it cools with height and condenses to form rain and downdrafts. Downdrafts are cool air rushing down and out of a thunderstorm. When cool air reaches the surface, it can't go down farther, so it spreads outward as wind. Downdrafts can produce strong, damaging straight-line winds. In this stage, strong updrafts and downdrafts coexist. The thunderstorm is at its largest during this stage, and this is the most dangerous stage of a storm, with hail, heavy rain, strong winds, frequent lightning, and sometimes even tornadoes possible. The dissipating stage is when the storm no longer has a supply of warm, moist air to maintain itself, so it dissipates. Only downdrafts remain, and only the top of the storm remains. Light rain and weak winds may continue. Basic thunderstorm types. The first thunderstorm type is the single-cell thunderstorm. This thunderstorm has one updraft and one downdraft. These tend to last about 30 minutes. There's very little tilt to the storm, so rain-cooled air quickly weakens the updraft. The single-cell thunderstorm can produce gusty winds and/or hail, and is most common in the summer around here. Another thunderstorm type is the multi-cell cluster. Storms often form in clusters with several different cells, often in different stages of development. Sometimes called training storms because each cell moves over the same area. These clusters can produce flash flooding. Individual cells don't last long, but the cluster can last for hours. Storms keep forming, maturing, and dissipating. This cycle can go on for hours if conditions are favorable. Another storm type is the multi-cell line, also known as a squall line. Continuous or nearly continuous line of storms. Can travel hundreds of miles. Main hazards are damaging winds, but can produce isolated tornadoes. This is common along or just ahead of cold fronts. So this far south it's going to be in the cool season for us, around November through April. The supercell is a special kind of single-cell storm that can persist for several hours. These are highly organized. The supercell, the entire storm rotates or spins. Rotating updraft can produce tornadoes, can produce very large hail and damaging straight-line winds. This storm type has the greatest likelihood of producing severe weather and tornadoes, but not all will. Now moving on to radar basics, the NWS uses Doppler radar to detect meteorological and non-meteorological features. Radars emit a beam of electromagnetic energy that scatters upon hitting particles in the atmosphere. After scattering, some of this energy is returned to the radar and the image is produced. A radar tower is pictured on the bottom right. The radar sits on a pedestal so the beam doesn't hit the ground, trees, or buildings. Inside the dome is a dish. That's what emits the beam of energy. The radar beam is emitted energy travels until a particle, such as rain or dust, is encountered. Once hit, energy is scattered in all directions. Some weakened energy returns to the radar, and the strength of this return determines what we see on the radar screen. This is what we see on the computer. The colors represent the strength of the returned energy in decibels. As decibel values increase, so does the intensity of rainfall. Greens indicate lighter rain, yellows and oranges are moderate rain and possibly lightning. Reds are heavy rain with lightning likely. Pink, purple, or white usually means the radar is detecting hail. However, that doesn't necessarily mean hail will reach the ground, but it is a sign of a very strong storm. Snow is harder to detect with radar. It will usually be green, like light rain, but if the snow is light enough, it may not show up on radar at all. Radar imagery has really improved over the years. The imagery on the left is from 1965. The image on the right is from 2007. Both images are supercells, but the blobs on the left are unrecognizable. We can see a lot more storm features with radar now. In addition to seeing the intensity of rain and thunderstorms with the reflectivity images, we can also see the wind speed and direction by looking at velocity images, like the one pictured on the right. The greens indicate winds moving toward the radar, and reds indicate winds moving away from the radar. The brighter colors indicate higher wind speeds. Meteorologists can see rotation on here and warn of a possible tornado. We can also predict straight-line winds and downbursts with this data. The blue circle outlines an area of rotation that meteorologists would want to watch for possible tornado development. Now we're going to look at how lightning develops. Positive and negative charged particles become separated in a storm. As the difference in charges increase, positively charged particles rise up taller objects like trees, houses, and telephone poles. A channel of negative charge will descend from the bottom of the storm toward the ground. A channel of positive charge from the ground will reach out. When these channels connect, the resulting electrical transfer is what we see as lightning. After the initial stroke, if enough charge is left, additional lightning strokes will use the same channel and will give the bolt a flickering appearance. Lightning can be cloud to ground or ground to cloud, can be intra-cloud, meaning within the thunderstorm cloud, or it can be intercloud, between different thunderstorm clouds. If you look at the map on the right, you'll see that Florida, particularly Central and South Florida, is the lightning capital of the U.S. The Southeast U.S. has the most thunderstorm days. The West Coast has the least amount of thunderstorm days. Thunder is the acoustic shock wave resulting from the extreme heat generated by a lightning flash. You see lightning before you hear thunder because light travels faster than sound. Lightning safety is important because lightning kills more people than tornadoes or hurricanes. Only floods kill more people. No place outside is safe when thunderstorms are in the area. Get inside a house or building. Enclosed vehicles are safe from lightning, but convertibles are not safe even with the top up. Also, open cab vehicles such as tractors or golf carts are also not safe. If you hear thunder, lightning is close enough to strike you. Again, you want to immediately seek shelter in a nearby house or building, and trucks and cars are also safe. You want to avoid tall objects like telephone poles and trees, and immediately get out and away from pools, lakes, and other bodies of water, because water is a good conductor of electricity. Shelters that are not enclosed are not safe. This includes picnic shelters, baseball dugouts, carports, and porches. Once inside, you want to stay off corded phones, computers, and other electrical equipment that you put in direct contact with electricity. Cell phones, wireless game controllers, and remotes are safe to use, anything that's not plugged into a wall. Household plumbing conducts electricity. So you want to avoid sinks and showers and bathtubs when you hear thunder. And you also want to stay away from doors and windows. Thank you for watching. The next video will be about severe thunderstorms and tornadoes.